Hello, my name is Jim Wilgenbusch, and I direct research computing at the University of Minnesota and am part of AI Leaf. Research computing has several different units, but probably the one that is most germane to AI Leaf is the Minnesota Supercomputing Institute. Although there's a large spatial component to the research that we're doing, and spatial is also a part of research computing and contributes greatly to this project. I think what excites me most about the AI Leaf and what it's doing is that while it's at the cutting edge of developing AI models and relevant data sets, it also has a focus on delivering those cutting edge models and resources to the people actually practicing agriculture. And so that, without a doubt, is one of the things that drew me to this project, and I think is one of the things that continues to excite me about it. I think, in particular, we get so absorbed in the models that are focused on language, and there's reason to be because many people interact with these large language models and are impressed with how human, in many cases, they sound. The problems that we're solving in the agricultural and forestry domain, however, capitalize on different forms of AI, ones in particular that integrate scientific principles with these large neural networks or machine learning networks. That's transformational. We've heard more and more that we need AI that does math. And what people mean by that is we need AI that incorporates some of the well-known and extremely well-studied scientific principles with the power of machine learning. And we're seeing that in AI Leaf, which excites me greatly. What I would really like to see, I think, in the coming months and years that this project moves forward is the accumulation of more relevant data set on which our models can be trained. Data are clearly the fuel for AI, and we are in a position to be able to accumulate those data, label those data, understand those data in ways that some of the more generic AI models just simply can't do. And so by bringing together not only the algorithmic expertise and the agricultural expertise at University of Minnesota, but also at our numerous partner institutions, we're able to get that broad perspective on what actual components of data will be needed to make the relevance of the work that we're doing more and more impactful to those people who depend on it. I'm excited about this project for so many different reasons. Among them, however, is our ability to bring relevant data sets to an area that has no limits and has an amazing amount of potential to transform the way that we view our environment, the way that we grow our food, and the way that we harvest products like timber. One of the reasons I say that is that this area in particular is full of interesting data sets. Those data sets, however, are incredibly variable. For example, we have environmental data, we have genomic data, we have management data, and we have socioeconomic data, all of which are relevant to solving some of the pressing problems that we face in forestry and agriculture. One of the things that we're doing in this project is looking at ways to better integrate those diverse data sets so that we can have meaningful impact that could potentially be delivered to farmers and foresters. This is critical, a critical component of the project because what we seek to do is take these leading edge models, which depend on these heterogeneous data sets, and translate the things that we can learn from these diverse data sets directly to those who are practicing in the field. And we're ideally suited, I think, in many respects here in this part of the country because we are surrounded not only by Fortune 500 companies and startup companies working in agriculture and forestry, but we're also in the middle of the land that is being used for agriculture and forestry. And so that combination of a leading edge academic effort that is developing leading edge techniques with area companies and practitioners, I think is something that has yielded and will continue to yield amazing results in the future.